everyone, in this video I'm going to discuss the most basic rules of taking derivatives. So we have the constant, power, sum and difference rules. I've put these rules together in one video because they go very well together, and actually once we know them we can do quite a lot. Now our first rule, the constant rule, says simply that the derivative of a constant is equal to 0. So I can notate this like d dx, the derivative with respect to x of c, our constant, is equal to 0. And we can interpret this as, how does our constant change if we increase x by a small amount? And the answer is there is no change, because we're talking about a constant and the value of the constant does not depend on x at all. So the effect is 0. So for instance, if I had y is equal to 4, 4 is a constant, so dy dx, the derivative of our function y with respect to x, is equal to 0. And this makes sense. The function y is equal to 4, it looks like this. Y is constant as x changes. So the slope and the derivative is 0. Of course, we can use any variables we like. For instance, if we had a total cost function, TC is equal to 5, then dTC dQ, the derivative of total cost with respect to Q, is equal to 0. 5 is a constant. Now here I am taking the derivative with respect to quantity Q because total cost typically is described as a function of quantity. And so this means as quantity changes, total cost does not change at all. The diagram would look like this. So the slope is 0, as is the derivative. So that's really easy, right? Our first rule, the derivative of a constant is equal to 0. All right, let's think about rule number 2, which I call the power rule. It is as follows: the derivative of a function, if it takes the following form, x to the power of n, we're going to take n and bring it out the front. So it'll be n times x, and then we take 1 off the exponent. Now this second rule is very useful. You'll probably use it a lot. So I suggest doing lots of practice. Let's go through some examples. If y is equal to x squared, then n is equal to 2, right? And x is just x, so dy dx, the derivative of our function y with respect to x, is equal to, well, the 2, that exponent, comes out the front, times x to the power of 2 minus 1, which is equal to 2x to the power of 1. Now when we have a variable that's raised to the power of 1, we usually don't include the 1 in there because it's implicit, so we just get 2x as our answer. And actually I showed this function in the previous video in this series if you watched it. Y is equal to x squared is a bowl shape like this. And the idea is that we can substitute any value of x into our derivative to find the slope of the function at that point, or rather the slope of the straight line that's tangent to that point. Let's think about another example. If a is equal to q to the power of 3, the derivative of a with respect to q, well, here our n is 3, so that comes out the front. And instead of x, we have q, so we'll put q to the power of, we take 1 off the exponent, so 3 minus 1. So we get 3q squared all up. All right, now if we add a multiple in front of our function, we just apply the rule as per usual. So we multiply the exponent through with that multiple. So just as an example, if y is equal to 4x squared, so if we've multiplied everything by 4, that doesn't change things. We just put 2, that's our n here at the front, and we get 2 times 4 times x to the power of 2 minus 1, which is equal to, well, 2 times 4 is 8, and we just are left with x there because when we raise things to 1, we don't usually notate that. All right, another example, if y is equal to 2 times x to the power of 4, the derivative of y with respect to x is equal to, we take the 4 out the front, that multiplies 2 times x, and we take 1 off the exponent. 4 times 2 is 8, and we're left with x to the power of 3. All right, good. Well, my third rule addresses when we have things added together. So that's the sum rule, and it just states that the derivative of 2 functions added together with respect to x is equal to the sum of the derivatives of the 2 functions in question. So this notation might be a bit confusing, my apologies, but all I mean to express here is that if you have a function where you have many terms added together, to take the derivative of that function with respect to x, we can just take the derivative of each term, and here our rule is treating each term as like a little function, which as it should, that's all right. And we can add those derivatives together. So for instance, if we had y is equal to 4x squared plus 5x, to find dy dx, we can take the derivative of 4x squared. So that will be 2 times 4 times x to the power of 2 minus 1. And then we can add to that the derivative of 5x. So we get 5 times x to the power of 1 minus 1. And 1 minus 1 is equal to 0. So actually that x variable will drop out there. In the end, we get 2 times 4 is 8. And that's multiplied by x plus 5. The x drops out because it's the power of 0, so it's just equal to 1. All right, another example. If v is equal to 4 times q squared plus 3q plus 4, well, the derivative of v with respect to q is going to be equal to, the 2 comes out the front, 2 times 4 times q to the power of 2 minus 1, and then we plus the derivative of 3q is going to be equal to, well, we just have 3 times q to the power of 1 minus 1, which is equal to 0, so that q will drop out, plus the derivative of 4, 4 is just a constant, so the derivative of 4 is equal to 0. So we're left with 8q, that's 2 times 4 times q to the power of 1, plus 3, that q drops out because it's to the power of 0, plus 0, so 8q plus 3 all up. All right, lastly, we have the difference rule, which is like the sum rule, but it just covers situations where we have subtraction. So the derivative of two functions subtracted from one another is equal to the difference between the derivatives of the two functions in question. So as an example, if we had y is equal to 2x to the power of 4 minus 5x, the derivative of y with respect to x will be equal to, we can just take the derivative of 2x to the power of 4. So 4 comes out the front, that multiplies 2 times x to the power of 4 minus 1. And then we minus the derivative of 5x. That will just be equal to 5 times x to the power of 1 minus 1, which is equal to 0. So that x will drop out. So all up we get 8 times x to the power of 3 minus 5. All right, we'll just do one more. Let's say we had the function TR total revenue is equal to q squared minus 3q minus 4. Then the derivative of total revenue with respect to quantity would be equal to, we take 2 out the front, that multiplies q, and we take 1 off the exponent, so 2 minus 1. Then we can take the derivative of 3q and minus that, so it will be minus 3 times q to the power of 1 minus 1, so that q will drop out, minus 0. The derivative of 4 is 0, so we get 2q minus 3 in the end. Now remember, in the previous video, I said that taking derivatives was related to the concept of marginal, which we use a lot in economics. Well, the first derivative of our total revenue function, which we found here, is marginal revenue. So we found marginal revenue. There you go. And actually, with these rules, you can get through quite a lot in my experience. I hope that helped. As always, thanks so much for watching my content. If you would like written notes to help you on your journey, or even just to support this channel to help me make more videos, you can visit my store. I have notes on introductory math skills for economic students there. The notes include lots of practice questions with solutions, which can really help solidify your understanding of the skills discussed in these videos. Also, if these videos have helped, please like and subscribe, comment below, share, all of that. It all helps. Any feedback is also super welcome. Thank you so much, everyone. Have a great day.